Assalamu alaikum, my dear students. Hope you are well by the grace of Almighty Allah. Welcome to an IUS school. This is Emdadul, Assistant Teacher of Mathematics, National University School, Dashi. Dear students, today I am going to conduct a higher mathematics class of class 9. Our today's topic is Chapter 2, Basic Discussion, and exercise 2, question 5 I will solve in our today's class. Okay, dear students, so let us see what we will learn in our today's class. It means our learning objectives. So at first we will learn variable, constant and polynomial. Variable, constant and polynomial. Dear students, in class 6, 7 and 8 you have seen algebraic expressions. Suppose I am writing an algebraic expressions here. I am writing an algebraic expression 3x square minus 5x plus 3x cube minus 5x square plus 2x minus 6. This is an algebraic expression. In this algebraic expression, if you notice here 3, 5, 2, 6, 3, 5, 2 and 6. These are real numbers, so these are known as constants. These are known as constants, as these symbols are expressing numbers, so these are constant. Okay, now x square, x cube, x. It means here x is an unknown quantity. X is an unknown quantity. The students, in any algebraic expression, the unknown quantities are known as variable, as the values of unknown quantities can vary. Okay, so this x is known as variable, and 3, 5, 2, 6, these are known as constant, as these are the fixed value or fixed number. So the symbol which express fixed number, that are known as constant, and the unknown quantity which the value of which can vary is known as variable. So x is variable here, and 3, 5, 2, 6 are constant here. And then we will learn polynomial. Dear students, you have seen different types of algebraic expressions. Suppose algebraic expressions containing one term. Suppose if I write only 3x, this algebraic expression contains only one term. If I write 3x square plus 5x, this will be only, there are two terms here. So if you see any algebraic expression contain one term or two terms or more than two terms, then all these are known as polynomials. It means that algebraic expression containing one or more terms, algebraic expressions containing one or more terms is known as polynomial. Okay, dear students, so we can say 3x cube plus 5x square plus 2x minus 6 is a polynomial, and here is, as only x is the variable, this polynomial is known as polynomial of one variable, polynomial of one variable. Dear students, in this case, if the polynomial has only one variable, then we can get the general term of the polynomial, and we can write that by c x to the power p. Here c is the constant, and p is also constant, but p is the index of the variable. P is the index of the variable. Here we need to remember that here, when p, the value of p will be larger, then the terms of the polynomial is known as the leading term of the polynomial. So here in the first term, value of p is 3, in the second term value of p is 2, in the third term value of p is 1, in the fourth term value of p is 0. And in this case you need to remember that 3 is highest here, it means the value of p is largest, 3. So this term 3x cube is the leading term of this polynomial. This term is known as leading term of this polynomial. Okay, the leading term of the polynomial, we need to notice, if we notice here, we will get the index of the variable in that term. That index will be known as the degree of the polynomial. degree of the polynomial. So the degree of the polynomial I have written is 3. Degree is 3, and the coefficient of the leading term, that is also 3, is known as coefficient of leading term. Coefficient of leading term, that is 3. So we can say here 3 is the leading coefficient. 3 is the leading coefficient, and the term 6. Here the index or value index of x is 0 or value of p is 0. P is 0 in the last term. So this term does not contain the polynomial. So this term is known as constant term. The term does not containing variable is known as polynomial. Dear students, is known as constant term. Dear students, now we will learn polynomial of two variables. Here the polynomial I am writing x square plus xy plus y square. This is a polynomial, and in this polynomial if we notice, here is a variable x, here is a variable y, so containing two variables here, so this polynomial is known as polynomial of two variables, and its general term can be denoted by c x to the power p y to the power q. In this case, the degree of the polynomial will be p plus q. In this case, the degree of the polynomial is p plus q. Okay, dear students, so we can say the polynomial of variable 3 now in this way: x cube plus 3x square y plus 3x y square plus y cube. So this is also a polynomial containing two variables. So we can write here another variable. We can write 3x y z. So this is a polynomial which contain three variables x, y and z, containing three variables, and this polynomial can be denoted by c x to the power p y to the power q z to the power r. In this case, the degree of the polynomial will be p plus q plus r. Okay, dear students, so you can say the degree of the polynomial you can determine easily. So for the degree, you need to remember that you will get the largest sum, and that will be the degree of the polynomial. Okay, dear students, so I have shown you the polynomial of variable one variable, polynomial of two variables, and polynomial of three variables. Okay, dear students, so polynomial discussion is done here. Now we will discuss equality of polynomials. Dear students, if I write a polynomial a1 x square plus b1 plus a2x plus b2y, this is a polynomial, and I am writing another polynomial here, not b2, that is a3. Suppose here b1 x square plus b2 x plus b3. This is another polynomial. These two polynomials are said to be equal. If the coefficients of the similar terms are equal. Here index of x is 2, here index of x is 2. So these two terms are said to be similar. So if the coefficient of the similar terms are equal, it means that if a1 equal to b1, a2 equal to b2 and a3 equal to b3, then the polynomials are said to be equal. So two polynomials are said to be equal if the coefficient of the similar terms of both polynomials are equal. Okay, dear students, so this is the condition for the equality of polynomial. Okay, dear students, now I will discuss the next topic, remainder theorem. What is the remainder theorem? Dear students, remainder theorem means if you open your book at page 47, you will get there proposition 1, that is known as remainder theorem. The theorem is, if P of x is a polynomial of positive degree, if P of x is a polynomial of positive degree and A is any definite number, then the remainder of the division of P of x by x minus A will be P of A. It means if we consider P of x is a polynomial of positive degree, suppose ax square plus bx plus c is a polynomial, then not ax square, we can write here x square plus, here if we write here px square plus qx plus r is a polynomial, of positive degree. Here the degree of the polynomial is 2, so this is positive degree. Then if a is any number, a is any definite number, then x minus, if we divide the polynomial p of x by x minus a, if we divide p of x by x minus a, then the remainder will be p of a, This theorem is known as remainder theorem. Dear students, if we get time in the next class, then I will show you the proof of the remainder theorem. I will not show the proof today. Okay, dear students, now I will go to the next topic, that is factor theorem and its converse. Dear students, if p of x be a polynomial, you can open your book at page 48. There is proposition 3. Proposition 3 is factor theorem. If p of x is a polynomial of positive degree, if p of x be a polynomial of positive degree, and if the remainder, it means p of a equal to 0. If p of a equal to 0, it means if the remainder is 0, then p of x will be divisible by x minus a. P of x will be divisible by x minus a. It means that x minus a will be a factor of p of x. X minus a will be a factor of p of x. Again I am telling, if p of x be a polynomial of positive degree and p of a is equal to 0, it means if the remainder is 0, then x minus a will be a factor of p of x. It means that p of x will be divisible by x minus a. Okay, dear students, so now I will discuss the converse of factors theorem, that is its converse of factors theorem. Converse of factors theorem means, here if x minus a, here the converse of factors theorem, it means if x minus a is a factor of the polynomial p of x, conversely we can say if x minus a is a factor of polynomial p of x, then the remainder p of a will be equal to 0. Again I am repeating, factor theorem means when x minus a will be the factor, when the remainder will be 0, then x minus will be the factor of p of x. But if x minus a is the factor, then the remainder will be 0. This is the converse of factor theorem. Okay, dear students, so I have discussed factor theorem and its converse. Now I will discuss homogeneous, symmetric and cyclic expressions. Okay, dear students, to understand this, at first I am writing homogeneous expression. I am writing an expression. Now see, if I write here x square plus 2xy or xy plus y square is an algebraic expression here. Now if you notice, the degree of the term, first term is 2, degree of second term is 3. Here degree of third term is also 2. It means that the degree of all the terms will be 2. Here the degree of second term will be 2, as degree of x is 1 and degree of y is 1. So the product of the degree of their product will be 1 plus 1, means the degree of their product will be 2. So in this case we can say the degree of the polynomial, degree of all the terms of the polynomials are same. If the degree of all the terms of a polynomial are same, then the polynomial is said to be homogeneous. Then the polynomial are said to be homogeneous, and this can be said that homogeneous expression. Then this expression is said that this is homogeneous expression. So for an expression to be homogeneous, the condition is the degree of all the terms must be equal. Okay, dear students. So now I will discuss symmetric expression. Symmetric expression. Dear students, now try to understand here. I am writing an expression here, xy plus yz plus zx. If I write this expression xy, yz and zx. Dear students, now interchange any two variables. Interchange any two variables. Suppose we are interchanging x by y and y by x. Now y by x. So here is x and y. So interchange x by y, that will be y, and y by x, that will be y into x, plus this will be x into z, plus this will be z into y. So what we are getting here, that is xy plus zx plus xy plus zx plus yz. So we can write arranging xy plus yz plus zx. What does it mean? We are getting the first expression. It means the expression is unchanged. If we interchange any two variables, the expression remain unchanged. So these two expressions are said to be symmetric. This expression xy plus yz plus zx is said to be symmetric expression. Dear students, so we can say if any two variables of an algebraic expression is interchanged and the obtained expression remains same, then the expression is said to be symmetric expression. So this is an example of symmetric expression. Now I will show you cyclic expression. Dear students, if I draw a circle here, now suppose here is A, here is A, here is B, and here is C. So these are revolving anticlockwise. So we can write, at first we can go from A to B, then from B to C, then C to A. So if we write any expression maintaining this order, suppose A plus B plus C, or AB plus BC plus CA, AB plus BC plus CA, we can write in this way. Dear students, this expression will be a cyclic expression. How this can be? An expression is said to be a cyclic expression if second one can be replaced by the first one, third one can be replaced by the second one, and first one can be replaced by the third one. So we can write here, if we replace the variable second variable replaced by first, third variable replaced by second, and first variable replaced by third, replaced by third. So we can replace first variable by third, so this will be C. Second variable by first, this will be A. So replace second variable by first, this will be A. Third variable by second, this will be B. And third variable by second, and first variable by third. So we have replaced second variable, it means B we have replaced by A, C we have replaced by B, A we have replaced by C. If we replace, then this expression remain unchanged here, AB plus BC plus CA. So this remain unchanged. So this expression is said to be a cyclic expression. Dear students, so definition of cyclic expression: an expression with three variables which remains unchanged when the first variable is replaced by the second, and second variable replaced by the third, and third variable is replaced by the first. If we replace in this way, so our expression will be unchanged, and then expression will be unchanged. Try to remember the condition again. First variable will be replaced by second, second variable will be replaced by third, third variable will be replaced by first. So if we replace in this way, this will remain unchanged, and this expression is known as cyclic expression. Okay, dear students, so I hope you have understood the discussion of today's class. We have discussed symmetric and cyclic. Dear students, now I am writing an expression. I will check this will be homogeneous or not. X by y plus y by z plus z by x. Will it be homogeneous? Dear students, if you see here, this polynomial has the same degree as here variable of degree same. So this is, you can say this is homogeneous also, but we are not checking the homogeneous here. In this case, just we will check this expression is symmetric and cyclic or not. We can check. If we want to check the symmetry, we have to interchange any two variable. Now interchange here. We will interchange x by y and y by x. So interchange x by y. So this will be y by x plus x by z plus z by y. So is it same? Is it same or not? Y by x, no y by x here. Z by x by z, no x by z here. Z by x, z by y, no z by y here. So this is changed. As this is changed, interchanging two variable, this is not symmetric. Now we will check this is cyclic or not. Replace x by y. Now replace x, replace y by x, replace y by x. So we can write here, and x by z, y by x, z by y, z by y, and x by z. So we will get here x by y, y by z, z by x. So x by y means this one, y by z means this one, and z by x means this one. It means that if we notice here, the expression remains same. So we can say this expression is cyclic, but this expression is not symmetric. So this is symmetric, which is cyclic, which is cyclic. But this is not symmetry. This expression is not symmetric, though this is cyclic. Okay, dear students, so we can say an algebraic expression may be cyclic, it may be symmetric or not. A cyclic algebraic expression may be symmetric or not. Okay, dear students, now I will solve the problem from exercise 2, problem 5. I have written here. I will solve this problem. The problem is if a factor of a polynomial x to the power 4 minus 5x cube, x to the power 4 minus 5x cube plus 7x square minus a is x minus 2, then show that a equal to 4. We need to show that a is equal to 4. We need to show that. Okay, dear students, to show this we need to apply the remainder theorem. We can apply here. If it is p of x, let p of x is equal to, we can write the given expression here, x to the power 4 minus 5x cube plus 7x square, x to the power 4 minus 5x cube plus 7x square minus a. We can take that is p of x. So as x minus 2 is a factor of, as x minus 2, or we can determine x p of 2 at first. Therefore p of 2 we can determine. So put the value of x is 2 to the power 4 minus 5 into 2 cube plus 7 into 2 square, 7 into 2 square minus a. So put the value here, calculate here. 2 to the power 8 means 4 means 16 minus 2 to the power 3 means 2 cube means 8, 8 5s are 40 plus 7, 2 square means here 4, 4 7s are 28 minus a. Now calculate here, these two are positive, so we can write here 44 minus 40 is minus a. So we can write here 4 minus a. Dear students, we can write as x minus 2 is a factor of p of x. So we can say p of 2 will be equal to 0 according to factor theorem. The remainder will be 0. So we can write here as x minus 2 is a factor of the polynomial p of x. So p of 2 will be equal to 0. That is, we can write here p of 2 means here 4 minus a. 4 minus a is equal to 0, or we can write here 4 equal to a. Therefore a equal to 4. So we have proved a equal to 4. What we need to prove? We need to prove that a equal to 4. Dear students, so we have solved the problem 5 we have solved here. I hope you have understood the solution of problem 5. Dear students, try to learn the basic of this chapter at home. Keep practicing at home. Avoid by your parents. Stay home. Stay safe. See you again. Till then, Assalamu alaikum.